Alright, hey guys, how you going? So I just wanted to give you, while you guys are working on Python, I wanted to do some tutorial on anything. So I'm going to go ahead and give you guys a brief run through of some of the simpler cryptography questions on pico2014. Uh, I already, so for those of you guys who haven't started whatsoever on Python, the last one might be a little um, confusing. We'll be covering three, which is Caesar, the Valley of Fear, and then Zor. So Caesar and Valley of Fear, you don't need any Python experience. For Zor, uh, it'll be simple stuff, just basic Python knowledge. So once even if you're not all the way through Code Academy, you should be fine with understanding what I'm doing. So diving straight into it. Caesar. I already solved these two, so I won't exactly be able to back it up. So for Caesar, we have encrypted.txt, which I pulled up here, and it's a big novel or something like that. Then we get wait a minute. Oh, Caesar, I'm confusing the two. So okay, Caesar, we have encrypted.txt, which is just a big blurb of things. So if you don't know what a Caesar cipher is it's just a rotation of the alphabet. So say we're encrypting ABC. Well, A becomes B, B becomes C, C becomes D, etc. Or it can have multiple rotations, and A can become C, B can become D, so on and so forth. So it's just rotating the alphabet. And so what we can do is just simply um, Google a Caesar cipher, and I found a really nice one here, and input our text, which I already did, but I'll do it just again just in case. And what's nice about this one is because it lists out the outcomes with each rotation. So we just go through here until we find one that actually makes sense. Did I pass over it? I probably did. Something's going on here. Oh, here we go. The secret phrase is this big thing. So we'd copy this and we'd input that into our answer. I already solved it though, so it won't let me do it a second time, which is kind of a shame. But that's a very simple one. That's the easiest one they have. Next one is a little step up, but it's still just logic based. Nothing complicated. So if we look at the hint, might each set of numbers represent a word in the passage? So it gives it away that it's a word. So we have these arrays of numbers, which is which is a set of 3. And if we actually pull up a small chunk of text, like I'm gonna take this for now. Like I have here, it's it's not a small chunk of text, but what we can do is we can notice that there's patterns with these numbers. So for starters, we notice that it goes in ascending order with the first one. And we notice that the text is organized into paragraphs like this. And then it gave it away that each is going to represent a word. So my first theory is that each of the first number is going to represent a paragraph. The second one can either represent the line or the sentence, and then the fourth is going to represent the word in either that line or sentence. So I already solved this, so I already know which one it's going to be. But if you were solving this the first time, say you'd go in and you'd try for paragraph and then sentence and then the word in the sentence. So that'd be paragraph 1, 1, 2, so 1, 2, 3. So there's not 9 sentences in here, so that could work. So now we're going to try lines. So paragraph 1, then line 1, 2, 3, 4, 5, 6, 7, 8, 9. Word 4, 1, 2, 3, 4. The. So that means that this first one's going to be the word the. So we're going to try that same pattern and say paragraph 4, 1, 2, 3, 4, line 2, word 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Flag, B flag. Alright, so that already gives it away because B flag is, that's kind of a reoccurring thing in pico2014. So I'm willing to bet that this right here is going to be equal to is. So let's see, paragraph 4, line 8, word 3. Okay, which one was it? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3 is. The flag is. Okay, so the next two should be what it comes out to. So you guys should be able to take it away from here. So 7, paragraph 7, line 1. 1, 2, 3, 4, 5, 6, 7, line 1, word 5, 1, 2, 3, 4, 5. Ceremonial. Okay. So that's equal to ceremonial. Alright, so then we'd enter a ceremony. Oh, whoops, I already have it in there. And then you're going to go ahead and solve for this one, which comes out to bond. Anyways, okay, so that again was a simple, just logic, figure it out type of thing. This one requires a little expertise. So they encrypted their blueprints to have zor.py. We open this and it's just a big thing which we can copy into our own Python file, so we can play around with it, and then encrypt it, which it's going to download as a file with no extension. So what you're going to do here, I downloaded it. Once you download it, open it in Notepad++, and you'll have this big string. Save it as a text file so that you can manipulate it in Python, and you'll see why in a sec. So it's gonna open up to be this big weird string of characters or whatever they are, and we're gonna play with it. But more importantly, now we're gonna look at the Python file, and or zor.py, and I already saved it, so, and copied it over and saved it, so I'll open that up and we can take a look at it. Test zor. Okie doke. So looking in here, we see a bunch of methods. At the bottom it goes to main. So main, you notice it imports the system module. And it's basically, what this is doing right here is, I'm just going to give a quick rundown. It's giving you a command line with arguments on it. So if we were to run this, it should just spit out the usage thing, saying usage is, yep, there we go. Usage is encrypt, decrypt, in file, out file, blah, blah, blah. So what we would essentially do is we would say like encrypt this file, so in.txt, probably can't title it that, in.txt, and then type whatever we wanted it to do, to be for the output, so .txt, and then the password, which we could say is ABC. So that's what we do in Python to say that, but we're not going to do that because that doesn't matter for us. But when we type that in, it's going to go to either encrypt or decrypt. And what we notice with decrypt is it just calls encrypt with that. So what that tells us straight away is that with this type of encryption, encrypting it is as simple as just encrypting it again. So it just goes back and forth. With a lot of other ones, like a Caesar cipher, it's just going to make layers and layers and encrypt more. No, this one just goes back and forth. So now we can, so we don't even need to look at decrypt. We can just pay attention to decrypt. So we see that it comes out with, and it gets past the input data, which is what we're going to be encrypting, and then the password. So looking here, it says key equals 0, and then it runs a for loop in the password that we inputted, and then it runs a bunch of gobbledygook that we don't understand just yet. So if you guys have done any Code Academy stuff, you'll see that what it's doing is it's saying key, which is originally equal to 0. So key is equal to key to the power of whatever this is. And I should probably explain what ORD and CHR are. ORD and CHR are basically, oh gosh, I should probably explain what Unicode and decimal is as well. Everything that we type in on in the computer, it has a decimal or Unicode value, or hexadecimal for that matter. So, for an example, if we go, oh, and I typed a quick information already. Oh, whoops, here. So say I type the letter A, the character A. That's more important. A is, when I'm typing that in, that it's basically going through a big process. But A is equal to 97 in decimal value. And one thing you can play around with this is if you guys are familiar with alt codes. Alt codes are basically I hold down the alt key, and then on my number pad I'm going to type 97, release the alt key, and it comes out with A. And so I can type alt 1, let go of the alt key, smiley face, whatever. All of the different things, different possible outcomes. And I pulled up here. So we're going to type in alt codes. Really, if you could find it, you could say decimal chart, but that's going to return a bunch of different things because decimal can mean a lot of stuff. But so we're just going to type in alt codes. Okay, so we pull this up here. I don't like that one. I don't like that one either. I like that one. Oh, but it's not full. Oh, here we go. This is good. So notice that we have all kinds of space, exclamation mark. They all have a value here in decimal, and it ranges from 0 to 255. And the reason for that is because it's going to be assigned a byte that has the value 0 to 255. So there's 256 possible alt codes. That includes all special characters, letters, capitalized letters, punctuation, everything. Everything has a certain decimal value assigned to it. So the functions, ORD or methods, or whatever you want to call them, ORD and CHR, are basically tools in Python for converting them. So if I have A, which is equal to 97, I can run ORD on the string of A to come out to 97. CHR is the exact inverse, where if I run 97, that's going to be, or input the Unicode value of a character, it's going to return that character. So remember that with ORD, you input the character and it returns the decimal value. With CHR, you input the decimal value and it returns A. And so an example of that I pulled up here is a Unicode converter. So if I type in my password ABC, it returns this. And these zeros you see here are just formatting. It doesn't matter as much. Like I can pull out these zeros and it's going to be equal to the same thing. So it doesn't matter much. That's just formatting. But returning to, so now that we understand what ORD and CHR are, what this is doing is this is taking each piece of our password and it's multiplying it by 2 and then adding 3, and then, so this is going to be a little more advanced Python, but this is a bitwise function that's basically turning it into a byte. And you guys will just have to take my word for that. Maybe I'll explain it a little more in depth later. But the most important thing that we notice this is we don't even need to pay attention to what it's doing here. All we need to understand is that it's returning a single byte. So our key, no matter what password we type in, is going to be a byte that's in the range of the decimal value. So that's going to be 0 to 255. So 256 possible keys, no matter what here. And I'll run this just to show you guys. Copy, new file, key. You know what, actually, key equals 0. Now we're going to say password is equal to ABCD. Then we're going to say print key. Oh, whoops. What am I doing? So let's go ahead and save that. Yes. Replace that. Now we're going to run it. ABCD has the key value of 32. Or ABSD, my bad. ABC run 103. So you notice that no matter what we type in, no matter how long it is, it's going to be in the range 0 to 255. That is very useful because that in cryptography or cybersecurity, that is a very low number. So what we can do with this is, we don't even know exactly what it's doing with that key, but straight off the bat we can think, key. We can brute force that. We can try every possible value for key because it's relatively low, only 256 possible keys. So once it has that, it passes the actual encryption function, the XOR function that's taking the key and looking at it. It's just taking the result and adding the, let's see, the Unicode to, so it's doing a bunch of stuff, but we don't even need to know what that is. We don't even need to understand it. We can just have this as a file. We can run our own modified decryptor. I have it somewhere here. Oh yeah. So I'll explain why we have all of this, but just oh whoops. Let's see. Edit this with idle. So we're going to go in, and that method, that XOR method we have, we're just going to copy and paste into here. And then we're going to run a for loop in the range 255 actually, because that includes 0. We're going to run XOR input data with the value I. Then we're going, or actually we're going to print that. Print that big ol' thing. Now we need to actually set the input data, and the input data we're going to have as that big blob of, I had it right here, this big blob of stuff. So if you follow my advice and you create it and put it into a TXT file, we're going to save that. A lot of you guys, and I actually did this originally, which I went back on, you could say in input data is equal to, and then copy all of this, set it to triple brackets or triple quote marks, paste that in there, and you could try to run that, but you'll notice that your file actually won't save because basically Python can't handle these special characters. So we need to read it into the file by saying input date is equal to oh boy, why am I drawing a blank right now? I had this working a second ago. Open encrypt did.txt.read. Looks like that's alright. Oh, we need to set that equal to string. That should work. Cool. Let's save that. Let's see if that works. I might have screwed up somehow. None. Why is it none? Oh, it's not returning for some reason. Oops. Return results. Let's see if that works. Oh, there we go. So, just like what we did with the Caesar cipher, we're just basically trying to decrypt that with every possible key value. Okay, so smart people would probably say there's a much easier way of decrypting it than going through and sifting through these to find every possible value and trying to find something that actually makes sense, but that's not so hard because you can just look. Oh, there we go, found it straight off the bat. This is a message for Daedalus Corp. Only our blueprints here. That. For the cyborg are protected with the password. The password is this number. There we go. That's our flag. So let's see if that works. And this one is one that I didn't actually solve before, so let's see if that works. It's going to be a shame if it doesn't. Submit. Oh, there we go. So it worked. Fun stuff. Anyways, so that's a basic intro to some of that stuff. If something didn't make sense, which there's probably something, contact me on Slack or email me or something like that, and I will be happy to explain something to you. Questions are always welcome because I realize that sometimes I kind of say something without explaining. But anyways, I'll see you guys probably within a couple days. I'm going to try to post another video. I'll see you.